Hello everybody, I've been asked to show a quick little video on how to make this quite simple part. This is just a test strip used for many different things in universities, colleges, in industry. But as you can see, this is actually split in half, two different directions. So no matter if you look at it this way, it's the same as this top section, or if you look at it split down the middle here, it's the same here. That means you can either do a design where you just do one side and then mirror it, or you can do, say, this left side and mirror it, or you can, because this is a very simple piece, you can just do the entire thing. For this tutorial, I think I'll just do the entire thing because it actually will show you a little bit more on how these are made and how you can relate things to each other. So it's important to note here that if we're under the assumption, because we have no idea otherwise, that these two dimensions are the same, that means we can just subtract 58 from the 75 to get 17, and then if we divide that by 2, that'll give us the length of each of these areas, which is 8.5. So we can see from dimension, the center region here is 5, the outer is 10, and these arcs, we're assuming they're all the same, which I'm sure they are, have a radius of 30. So what we want to do is, I'll pull it up on my other screen here. So we want to start a new sketch in Fusion 360 here. I'm going to choose the bottom here because if we 3D print this out, I have this set up so the Z-axis is actually heading up. Not all CAD software does this, and it's not really important, but it does mean that you can just load this into the slicer and then instantly print it out. So I'm going to make the sketch on this bottom section here. Now, as I said, we can either do a half width or a full width, but first of all, let's get into parameters, because parameters are very useful. So if you click this FX button, you can change parameters, and then you can add your own. So if you enter a name of, say, total length, then it's defaulting to millimeters, which is the default I have set, and what I'm assuming this model is. So enter it here, 75 millimeters. Then we can do that. So what I want to do, because I know that each kind of landing length, I guess you could call it, is 8.5, I'll do that here. So landing length, we'll do 8.5. And then we'll do arc radius is 30. This will not be in millimeters. This is an actual angle. So 30 degrees for this one. And then we also have that center portion, which is 5 millimeters here. So width is 5, and I believe I don't have the overall width either. No, I don't. So I'll just go total width because it's my outside dimension, and then I will do that as 10. So these are the parameters I've got setting up here. This makes it so when you design a part, if you, say, want to increase the length or the total width or anything, you can just come back in this parameter thing, change these values, hit OK, and your entire model will refresh based on those values. So that will make things easier if you ever do want to change things aside from that. So because I said I'm doing the long way, I'm actually going to just go from the origin here, and I'm going to go left and up. As I said, there's multiple ways you can do it. You can do 1/2, mirror it. You can even do a quarter of it, mirror it the one way, and then mirror the other way if you wanted. But for simplicity's sake, and just to show a couple things, I'm going to do it this way. So what I'm doing, so length here, it doesn't really matter how long you make these from the get-go. We can dimension them afterwards. So, let's see. So hit D to dimension. We can do this. Did I do total or overall? Oh, there we go. So Fusion 360 is nice because as you type things in, it will actually show you things matching that description within your parameters. Not all software does this, and I wish they all did, but because normally I use Libra, which does not do this, and it does annoy me. And so we can zoom in here. This was, I think, landing. Yeah, landing length. Right there. Hit enter. Now, what we can do, instead of dimensioning this side as well, we can actually use this equals. So what we can do is do equals equals. You'll notice that is now the same length, and they have these equal signs beside them. Now what we want to also have is the length above, and we basically want to replicate this above. So I'll just do a line here, another line, and then I could have actually gone up from that. Would have saved me a step, I guess. So what I can also do here, I can do this equal to that. Cancel out of the operation, because if you don't, then they'll all end up equal, and that's just a pain. And then we can do that equal to that. There we go. Now what we want to do is we want to make sure that this is coincident with the line going up here, just to make sure it's all locked in. What was my coincident? Coincident. Like I said, I normally use Libra. Oh, it's already? No, it's not. Interesting. I just did this earlier and it was fine. Huh. If you ever find, because like I actually did this part earlier and I was able to coincident it with this green line. I'm not sure why it's not right now, but if you ever find yourself in a position like that, what you can do is just make a line and then right click and go normal/construction. This turns it into a construction line. So what you can then do, because this is locked in now, you can modify the length because I haven't mentioned that, but you cannot actually modify that. Fusion 360 automatically made it a perpendicular. So what we can do is we can just coincident it to that line. Or even to that. It went to the node there, which is fine. I don't care about that. I just want it going straight up. Now, we can dimension, so this will be dimensioned end to end, and that will be our total length. There we go. And you'll notice it shot up. Great. So what we also have, we have to actually keep in mind that we're going from a center point of this for where we want that 5mm line. So what I'm going to do is I'm going to create a line, and if you see right there, it makes an X and a little triangle. That triangle indicates it's actually the midpoint of the line. So what we can do is we can just do that. I'll again make this a construction line. And this is just the base our 5mm off of. So now we can actually just willy-nilly plop down some lines, which are going to be perpendicular to the base here, because they'll be straight up. And you'll notice it fills it in with a shading that indicates it's a closed box. And then we can just dimension from this line to that line. What did I call this? Inside. Oh, center. Oh, I misspelled it. It's center width, though. And then because this will be half, we can go divided by 2. And you'll notice it changed it to saying fx, meaning that it's a parameter, and then the total is 2.5. So we can center divided by 2 again. There we go. Those are both locked in. And notice everything is now black. That means it's all fully defined. Now, what about those arcs? We have to go here. Now there's several different ways. We can do a 3-point arc, which is the one I would probably do because it's a little less finicky. We can do a center point arc, which I find kind of backwards, or we can do a tangent arc. The problem in this scenario with the tangent arc is it might not create the tangents as we want them, because it'll try and create a tangent on both sides. So it might actually try and flip outwards instead of inwards. So for this, I'm going to do a 3-point arc. And I'll just put it anywhere on the line, really. And the end point here, and I'll make sure to stretch it in here. See? There we go. And yeah, it creates a box. There we go. Ooh. See, if we did the other way, it might have tried to go out there, or make a arc like this is what it would probably try and do if we did the tangent. You'll notice that actually did create a tangent relationship there. It's, as I said, we are actually creating tangent arc there, but, and it did for all these. But that doesn't really matter. So we can once again dimension these, and ours is the, arc. Oh, I misspelled that again. Jeez. 2 misspellings. That's fine. Eh? I'm not sure what made a space there. Arc radius. Yeah. Okay, let me check out. Let's make that arc, and because that annoys me, arc radius 30 degrees. Okay. Oh, right. Sorry. That actually should be a millimeters thing and not a degrees. That is my bad. Let us... Actually, it's probably easier to delete that and then just make a new one. Sorry, that was my bad. That's just because it's not actually a degree radius that we're doing here. It's a dimension to the center point, and that's why it wasn't actually working for me. So that is my bad, and that's why it wouldn't accept it. As you can see, it actually has a center point here, and then it goes to that. So that is my bad. And what we can do is we can just, once again, we can make these equal. And these equal. There we go. Now, you'll notice that we still have these lines. When we actually go to make a part, Fusion 360 is smart enough, it'll actually recognize that there's multiple of the same, and you can multi-select them, but not all CAD software is like that. So what I would say is trim, which you can hit with the T or just a little scissor command, and you can trim these. Now, because you can see the 58 on that, we can actually inspect, and we can go to the points here and make sure that's 58, which it is. So you can see distance 58 right there. So this is fully defined, fully set up. We can finish the sketch. We can extrude it, and this actually has a width of 2, which I did not make a parameter for, but that's okay. And now we can see we have an actual part. I hope this helps.